3.3, still in our matrix world, and today we're looking at a new thing as reduced row echelon form. So this is like the greatest thing about matrices and solving systems of equations. We're going to look at another method today that should make you very happy and help you solve systems here. So solving a system using matrices in reduced row echelon form. We looked last time at inverses and how they can be used. Remember that a minus a to the negative 1 or inverse b. Well, this way's even easier. And here are the steps. So if you're given a system of equations like we have before, what you need to do is first arrange them, make sure the x's and y's are in one column and also the equal to, and we're going to make what's known as an augmented matrix of this whole system. So just like we did before, we're going to make a new matrix. Now this time, we're going to make it a 2 by 3 matrix. We're going to put everything into one matrix. Okay? Now, these are the coefficients again. So 4 and 1, and 3 and negative 3. And in the same matrix, we're going to put that 1 and negative 1. So let's get into our calculators, and we're going to type that matrix in. So second inverse, over to edit. And we can just put this right in matrix A. So we need a 2 by 3. And we're going to put all those numbers in, 4, 3, 1, 1, negative 3, and negative 1. Be careful typing these into your calculator. It's very important that you catch the negatives and you put those in there. So I entered that into my matrix, and we took care of 1 and 2. Now, leave the matrix and go back in. And this time, we're going to enter the matrix, go over to math. Okay, there's a few other terms here we're not going to look too much into. And we are going to go all the way down to R, R, E, F. R, R, E, F. And that is our reduced row echelon form. So we're going to hit that. We're going to hit R, R, E, F. And it's going to ask you, what matrix do you want to do this operation to? And we're going to hit matrix A. Now we're going to hit enter, and the magic's going to begin. Now, what does this mean? Okay, let's make it into a fraction. So math, enter, enter. And what we have, so our solution, just going to write this down, is 1, 0, 0, 0, 1, and 1/3. Now, to the untrained eye, this is just a funky looking matrix. But let's break this down, okay? Remember, in this first column, these are all the x's. In the second, these are corresponding to the y's, and we have our equal to. So if we were to put this back into algebraic terms, we have 1x plus 0y equals 0. And we have 0x plus 1y is equal to 1/3. Now, if you haven't already caught on, well, 0y doesn't really exist, nor does 0x. So that just solved that system for you very quickly, and x equals 0 and y equals 1/3. Don't believe me? Use substitution, elimination, and there is your answer, folks. It is simple as type in the matrix into your calculator and reduce row echelon form RREF. Now, even better, we can use this for systems of 3 variables. So let's check this one out. So first, I would like you guys to be writing the augmented matrix. And we are again going to put all the coefficients and all the numbers. This time, we need a 3 by 4. 3 by 4. You don't have to draw the dashes, but I think they're helpful. So 3 by 4. Coefficients of x, 1, 2, and 3. Coefficients of y, -1, 3, -2. Coefficients of z, 1, -1, -9, and the equal to 8, -2, and 9. So that is what we'll put into our calculator. I'm just going to re-edit matrix A, and we can just make it a 3 by 4 and just rewrite over the cells. And the last row, again, be careful with negatives. Just takes one little mistake to throw it all off, so I'm just checking that. Leave the matrix, go back in, over to math, and down to RREF. So the augmented matrix, we're going to use RREF. Reduced row echelon form. Boop. And hit enter. Call out our matrix. Hit enter again, and lo and behold, we get this. So 1, 0, 0, 4. I'd like you to write these. 0, 1, 0, -3, 0, 0, 1, and 1. Now, again, what this corresponds to is I just have one x, I don't have a y, I don't have a z, therefore x equals 4. The second row, y equals -3, and the third row, z equals 1. So check that out. I know you're like, why did we do that substitution elimination? It was so challenging. I just wanted you to learn the algebra behind it, and then from there. If you're curious as to what is going on, the calculator, as it's doing RREF, is essentially doing all the substitution and elimination for you through the use of matrix row operations. Okay. Now, there are some special cases, so remember there are no solutions and infinite solutions. So I just want to show you what those would look like. For this case here, we have 4 rows, and we are going to have 4 rows and 4 columns. So just a little bit of a bigger matrix here. And I just want to show you what something is going to look like for no solution. So again, we'll just plug in our coefficients. -1, -3, -5, 12. So notice we can use this reduced row echelon form for some big systems here. And we need a 4 by 4. Just going to let my calculator do that work. And 1, -1, 2, 2, 2, -3, 2, and 1, 3, -5, 2, and -3, and -4, 12, 8, and 10. Okay, let's use reduced row echelon form on that. Hit enter, and now I get this funky looking matrix. So as we use RREF, we get this matrix here, 1, 0, 4, 0. 0, 1, 2, 0, 0, 0, 0, 1, and 0, 0, 0, 0. Now, if we had to now put this back into algebraic terms, let's see what we have. In this first row, this is saying 1x plus 4z equals 0. In the second row, it's basically saying 1y plus 2z equals 0. This third row, there's no x, there's no y, there's no z. It's saying that 0 equals 1. and the last row is 0 equals 0. Now, right here, okay, at this point, when you get 0 equals 1, well, that's not possible. You can never have 0 is equal to 1. So that just means this is an example of no solutions. Okay, you may have some different ones that come up, but that is just no solutions for that one. Okay, so if you ever come across, and they're all going to look a little different, but if you get a row that has something with all zeros and then a 1 or any number, this could be any number, in that other column, that is where it's no solutions. If, okay, so an example with infinite solutions, it's going to look similar. Say you do RREF and you get something like 1, 0, 4, 0. So it's going to be similar, and maybe 0, 1, 2, 0. And the last is just all zeros. So let's just say that's a little different. We're missing that other row. Here, again, we have x plus 4y is equal to 0, and we have y plus 2z equals 0. Then we have 0 equals 0. Okay, so that last little bit here, this is always true. 0 is always equal to 0. Okay, so that would just mean we have infinite solutions, and we'll actually look a little more into that when we get into word problems. So infinite is if you get 0 equals 0. No solutions at any point. So I know we have that here, but the no solutions overrides it. So if you get an inconsistent row there where 0 is equal to some other number, then it's no solution. So be careful with those. What I encourage you to do is look back through some of your old three-system practice. So old practice of systems of three variables, and try this method out. Okay, see how fast it is, and I'll reshare that document with you. But now that you know how to use RREF, check it out and try that new strategy. So good stuff, everybody. Quick lessons today. Should be enjoyable, and have a nice rest of your day.